This video will demonstrate how a Cisco switch with an interface configured for 802.1x authentication can allow anonymous voice VLAN access using Cisco Discovery Protocol. An advisory for this vulnerability was released by internetsecurity dated June 8, 2005. I won't get into great detail about 802.1x, but I'd like to mention that 802.1x is an IEEE standard for port-based network access control. When the supplicant is connected to the .1x configured port, the port becomes powered on. However, the port will remain in an unauthorized state until the supplicant can complete the authentication process. In this scenario, the supplicant/PC did not supply a valid certificate to the authentication server. So what does this mean for the port? It means the port remains unauthorized. Okay, well how about the phone? What if the phone cannot perform or act as an 802.1x supplicant? This is where Cisco Discovery Protocol comes in. When a Cisco IP phone is powered on, a CDP packet is sent from the phone to the neighboring switch. Inside that CDP packet, you can find tons of information about the phone. If the switch determines that the connected device is an IP phone based on the CDP packet that it received, the switch will then place the phone in the voice VLAN, giving it access to the network. So if we take a look at the switch port configuration, you'll notice that there's a sticky entry for the IP phone on the voice VLAN. You'll also notice that there's no sticky entry for the access VLAN. This is because .1x has prevented unauthorized access of the PC that could not supply a valid certificate. Okay, great. Now that we understand how access is granted to the voice and data network, let's see if we can achieve access to the voice VLAN using this Backtrack 2 CD. Assuming that port security and MAC sticky is enabled on the switch port, we will need to clone the MAC address of the IP phone. This can be achieved by reading the back of the IP phone or by going into Settings and Network Configuration. Once the phone's MAC address has been cloned, we can then unplug the phone and plug the PC directly into the switch. You'll also need to set yourself up with a static IP address. Feel free to make this IP address completely random, as we'll only use this IP address during the next step. So now we're going to use the Cisco Discovery Protocol spoofing utility, creatively named CDP. And what CDP will allow us to do is craft a CDP packet, one that resembles a phone, allowing us to masquerade as a Cisco IP phone and gain access to the voice VLAN. The utility is going to require that we enter some parameters to create the CDP packet. Most of these parameters can be pulled directly from the phone, such as the MAC address, the software version, the IP address, the host type, and the port. Okay, so after spoofing the CDP packet, the switch is now convinced that the PC is a phone. It's placed the PC's MAC address onto the voice VLAN. So now we need to create a virtual interface for 802.1q VLAN tagging. What we're going to use is a tool called VoIP-Hopper. VoIP-Hopper can passively listen on the network and find CDP packets and then assign that VLAN ID to that virtual interface, or we can manually specify it. It looks like VoIP-Hopper's discovered a CDP packet, assigned itself a virtual interface, and requested a DHCP address. To test our access, let's try and ping something on the voice VLAN using the new virtual interface that we've created with VoIP-Hopper. Let's see if we can access the data VLAN. A lot of times you'll see administrators will not implement ACLs between VLANs.